Hi, I'm Shri, and today we're going to be setting up Toffy on the CAC. To get started, we'll be installing Toffy on the CAC, but in order to do this, we need to install the following prerequisites: C++ build tools, Git, which is used to keep Toffy up to date, and Anaconda, which houses a lot of the extra libraries that Toffy uses. Next, we'll install the Toffy library itself. And then using Toffy, we'll be navigating the directories on the CAC that it creates. We'll be performing image co-registration, and then we'll be taking a look at the sensitivity tuning curve. The README contains installation and usage instructions for Toffy. If you're ever confused, please give it a read. Before we install anything, we highly suggest that you contact IonPath for the administration information for your computer. In the email subject, please put your lab name and your machine ID in brackets, and then put your issue or your question that you have afterwards. For example, Angela Lab M13 and P9, these are two machines that we have, so you can separate them with a comma. And then our request, CAC admin access request. Once you have all the administrative privileges that you need, we're going to install C++ build tools first. You're going to want to head to visualstudio.microsoft.com/visual-cpp build tools. Click download build tools. You're going to open the exe. Click yes so that Visual Studio installer can make changes. It'll go ahead and download and install. Next, you're going to want to click desktop development with C++. This will also go ahead and install, and then it may or may not ask you to restart your computer. Go ahead and do so. Next, we're going to install Git. Head to git-scm.com and click download for Windows. And then you're going to want to download the 64-bit Git for Windows setup. In the setup process, it'll give you a lot of options to choose from. We highly suggest that you leave everything in its default state. Once it's all done, go ahead and open your command prompt and type git-h, and then you should see the following help commands printed out below. Next, we're going to install Anaconda. Anaconda will allow us to download all of the Python requirements for Toffy. We're going to head to anaconda.com and click on the green download button. Next, when you open the exe up, go ahead and click next. And then for the installation type, choose just me. And then go ahead and leave the destination folder as to whatever it recommends. In order to make sure that Anaconda is installed properly, go ahead and search Anaconda prompt in your Windows search, and you should see Anaconda prompt, the app, pop up. Now we can go ahead and proceed to install Toffy. Head to the Angela Lab Toffy GitHub page, click on the green code button, and go ahead and click on the copy icon. This will copy the GitHub link. Next, you're going to want to find a place to save Toffy. I recommend Documents, so in your Anaconda prompt, change directory into Documents. Once you're there, go ahead and type git clone, and then paste the link to the repo. And then once it's all cloned, go ahead and change directory into Toffy. Then we're going to create the conda environment with conda env create-f environment.yml. And this is going to create the environment. And then you can activate the Toffy environment by calling conda activate Toffy _env. Make sure the name is spelled correctly. If you just do conda activate Toffy, it will not run. Now with Toffy installed, we can start with the first notebook, which sets up Toffy. Next, you're going to want to run jupyterlab -- allow root, and then a web browser like this should pop up. Go ahead and double click on the templates folder, and inside of templates, you'll see all of the following notebooks. Before you edit any of the notebooks, we highly suggest that you duplicate them. This is so that you don't get any conflicts whenever we decide to push changes out, and then when you decide to download those changes. Now with Notebook 1 opened, we can go ahead and create directories on the CAC. Go down to Section 1, Create Necessary Folders. This will create all of the folders in the C and the D drive that we need, In the D drive, it creates extracted images, and then creates Rosetta compensated images, then normalized images, and then finally your cohorts. And then in the C drive, in users customer.ion documents, it creates tiled images JSON, auto-labeled TMA JSON, panel files, run metrics, watcher logs, Rosetta matrices, Rosetta testing, and then normalization curve. If you'd like to learn more about all of these, it's in the README. Next, we're going to go over image co-registration. Head to the instrument control webpage, and then in order to display the location of the FOVs on the slide image, we have to map the location of the actual pixels in the image to the stage coordinates on the slide. Go ahead and click Inspect Element, and then in the console, type logger.level equals 4. And then on the slide itself, you're going to want to acquire target points for the various stage coordinates. With that information, the optical coords will be given to you from the logger, and then using both of those, you'll read the fiducial info in the notebook, and then it'll ask you to input the X and Y coordinates of the stage, and then the X and Y coordinates of the optical. And this will be done for various parts of the slide. Only run this when IonPath changes their co-registration. Next, we're going to generate the sensitivity tuning curve. The sensitivity of the detector will slowly decay over time, decreasing the counts recorded for the same amount of true signal. We use median pulse height as a metric to evaluate the sensitivity of the detector. Head down to section 3 of the first notebook, and we'll create the following curve. As an illustration, here's this curve. The x-axis is detector gain, and the y-axis is the percentage of max signal. It should look qualitatively like this. However, it is okay if the actual values are slightly different. In the notebook itself, you're going to first pick a sweep name, which will then be where this curve is stored, and then you're going to create the tuning function. You do this once per CAC. In summary, we have now installed Toffy and its requirements. We've set up the necessary folders on the CAC to allow for easy processing. We've set up co-registration, and then we've created the tuning curve. Coming up next, we'll be looking at how to create a run.